Hello, I am Chrysanthi. I am career counselor from Greek Public Employment Service, and today I'm going to present you a pilot study about HR and artificial intelligence, specifically NLP, natural language processing. But let's start with the challenge. Which is the challenge here? Well, in Greece, we have many employers that they complain that they cannot find the right person for their job vacancy. On the other hand, we have many candidates that they are looking for a job, they are specialized in the field, but they cannot find a job at the end of the day, and they choose to go abroad. So here we have some consequences. First of all, we have a knowledge here that is going to another country, so we're losing knowledge. At the same time, we're losing money. And when I say we, I mean the country, the Greece is losing money because people are going abroad to spend their money. Moreover, we have invested time to people to get this specialized knowledge. So when they leave, we have also lost an amount of time. And at the end of the day, of course, this mismatching leads to unemployment. It raises unemployment. So actually, it also creates a vicious circle. So people are looking for a job, but they cannot find the job that they want. On the other hand, we have employers that have the jobs, but they cannot find the correct people, the right people for the right job, as I said before. So that's the question. Could AI help us to improve this matching and break the chain of this vicious cycle? Well, let's see what NLP means. What we mean when we say natural language processing. Well, NLP is a branch of artificial intelligence that let's say that teach a computer to understand our language the same way that we do. So the computer will use the same words that we use with the same meaning. So if I had to give you an example, this is the one. When I say office software, it will understand that I mean software that create or edit documents, spreadsheets, presentations, of course, etc. So we are talking with the same words and we mean the same things. That's what NLP does. So in this pilot study, what we did was to get some CVs and some job ads that Greek PES had in their database. So we have 50,000 CVs of registered individuals, random sample, of course, so we could have a representative sample here. And from these CVs, we use only work experience, education, trainings, skills, work preferences, and we don't use the gender, the age, and any other detail that is irrelevant with the job, the actual job and the qualifications and skills. What we have to remember here, in this pilot study, we have words. Most of the times when we are talking about a research, we are thinking about numbers. Now we have words, not numbers. So we have to make them look like same, let's say. Somehow we have to normalize them. In order to do this, we have to get the text and remove stop words such as I, he, she, or the articles the. We have to remove also links, numbers, punctuation. We have to remember here that all these data are in Greek. Okay, so what I'm saying here, I write I, he, and the there, but I mean in Greek, the could be o, I, to. So we have 3 words only for this. So of course we convert all the letters in lowercase, and somehow we have normalized the text that we are going to give to the computer to understand, let's say. When we do this, we can create a CV space. As I said, we had the CVs, we had the text of each CV. We normalized somehow that text, and now we ask from the computer to create a space. In this case, we used word-to-vec technique, and we had 100 dimensions. And we said to the program to generate a CV space, and this is the space, let's say, this is an example just to make it more visible, of the space that we have. Here we have 2 dimensions, but we ask for 100, okay? Each dot here represents a CV. So, after that, we said we have the space of the CVs. So you saw that before. Now we have to see the job vacancies here. We asked for 50 job vacancies, again, random sample, and from these vacancies we choose to keep specialty, job description, qualification, and every other detail that its job vacancy may have. We do exactly the same that we done with the CVs, which means that we remove punctuation, we remove numbers, stop words, he, she, etc., etc. And then we had the space. You remember, we have created the space. So the only thing that we need now is to get the coordinates from this job vacancy. From this 50, think one that we have. For each one, it's one job vacancy. We ask for the coordinates. And then we put it again in this space. So the red one, that's why I didn't say before what was the red one. The red one is one job vacancy here. Since we had the CV space and now we have also the job ad, the only thing that we need to find is the closest CV to this job ad. We have to actually count the distance. So Manhattan distance is the distance that we use to count, in this case, which CVs are closer to this job ad. Now, I said before that we created a space, okay? But this space has some dimensions, but also has some dimensions without having numbers. And this is kind of weird. So we have to check a few things to be sure that it's a right way to do it, or it works somehow satisfied. So one way to do this is to find similar words. So in this case, the first thing that we did, we asked about hairstylist. So we have to give us the similar words from hairstylist, and it says care and hair. Of course, as I said before, we have Greek words in our model, in our data. So in the first line I translate in English, but in the second line I have it in Greek, just to be sure that we are talking about the same thing. After that, since we see that similar words are okay, are satisfying, we go to the next level and we are going to check the matching, and we're going to check the 10 closest CVs from this job ad. I said before that we had the red dot was the job ad, and we asked for the 10 closest CVs of this job ad that we saw before, the red dot, I mean. So the job ad was about a secretary, and it brings us a person that has a degree in business administration and also wants to work as a secretary or office staff or filer. So we can see that it works. It seems like it's okay. Even if this was the first person. The second, actually the third, was a person that didn't have a secretary as a job that was looking for, but also had the profile that the secretary needed to have to get this kind of job. So it seems like this model works okay. But what we have to see here, and we have to improve and remember, first of all, we have to remember that in this case, we have to use limitizer or steamer. In case we don't know what they do, let's say that we have a CV, and in this CV, someone writes, I am adaptive. And let's say now that in the job ad, someone wrote skills that the candidate must have, adaptability. If you use limitizer, both times it will make adaptability adapt, and adapt, it will gonna keep it as it is. So it's gonna keep the lim. And this is even better. It has to be. It will improve the model much more. But at the time, I wasn't able to find a Greek lematizer, or a steamer at least, that was used for Python. So this model needs absolutely a Greek lematizer or a Greek steamer. We have to check about it. So the second thing that we need to have in mind is that the model must be improved if we're going to integrate it. And of course, it has to be tested for a larger scale. And how we can do it? One suggestion is to keep the same way that career counselors are working right now, and ask from this model to, of course, with the improvements that we said before, ask from this model to give you the same amount of CVs. So we have an ad, a job ad. We have to ask from career counselors to bring us the 10 CVs that fits more in this job ad with the same way that they're working till now. And then we need to ask the same thing from this model. And someone else, a third-party person, should review these two and check that at least they have to be in the same page. If the model is not better, but it's equal, it's okay. If the model is not equal, but is less, then we have to improve this model and it doesn't work. Now, the last thing that we have to remember is that this model gives us the opportunity to use free text. Till now, in Greek, most of the time we use, most of the time we use on-off criteria. So, let's say, I told you before that the secretary, the first person had the secretary as a preference job, but the third person didn't even wrote secretary somehow. But the profile was okay for this job. So, this is what free text does. We can use free text. We don't have to have the same language, the same letter, the same words to understand that this person has the same qualification with the other person. Different words, but with the same meaning. This model can use it, can get it. Till now, we don't have it. We have, when we are looking for secretaries, we're going to check only for people that have said that they want to work as secretaries. If they just said office staff, it's something else for us, and they are not in our list of CVs, let's say. So in this case, with this model, this doesn't matter. It doesn't really matter. So if you have the profile that a job needs, you are going to be there. Of course, before I leave from here, we need to remember that AI is going to support the process. It's not going to replace people. It is going to give us let's say 10 CVs, 20, 100, whatever the number is, but it's not going to pick one for us. We have to be there. We have to be aware of pros and cons of this model and to check every time that this CV is okay and it's going to pass to the next level. We can use this model for many things. First of all, you have to remember the on-off criteria that I said before. But something very important in this case is that this model is not a trained model. Not a trained model with data of CVs that got hired at the end or not. So it doesn't reproduce our stereotypes. As I said before, we haven't used the age or the gender in this model. And that's the reason why was to, let's say, avoid some kind of discrimination. So in this case, every time, it doesn't really matter if a person is disabled, the age of the person, the gender of the person, or any other personal detail that may discriminate him or her. In this case, we just have the data, the qualifications, skills, experience, the things that really matters when it comes to a job, to a work, and to a working environment. So it improves matching with many ways, but also somehow it improves the way that HR process is happening, because most of the time stereotypes that we have, it's not something that we have it and it's in our mind and we can understand. Most of the time it's in the background. How can we use this model with other ways? Let's say we saw that we can have a matching when we have a CV space and a dot and we find the closest CVs. Okay, that's the first way to use it. Another way to use this kind of models may be to help us to explain to a person what to improve to get his or her ideal job. The other thing that we can do with this kind of model, this kind of AI use, let's say, is to help people to change career much easier. Last but not least, we can redesign the content of training programs. So here we have some references that were used in this presentation, and of course packages and libraries, the main packages of Python and libraries of Python that were used in this pilot study. I'd like to thank you very much, all of you. I'd like to remind you that from my perspective, AI is a tool. We can use AI to improve processes or to improve or make quicker some of processes that we already use, but we cannot replace the human factor. That's my opinion. That's what I have seen till now. Now, whatever you have, if you have any question, I am here, but also you can use my email or my LinkedIn profile. You can contact with me with any way and that you choose. And thank you very, very much for being here.